Hello, everyone. I'm Catherine Schmidtke, and I'm pleased to welcome all of you to the 10th year of OCP. I'll be talking about OCP past, present, and future. A decade goes by so fast in the technology-driven world that it's good to take a moment to consider what's been accomplished. 10 years ago, many of the things we take for granted today were just in their infancy, and some did not even exist. For example, look at how computer vision technology has evolved. It was back in 2012 that Alex Krizhevsky published AlexNet, which is considered one of the most influential papers on computer vision and changed how computers see the world by evolving from an algorithmic methodology to one based on neural networks requiring training. The transition was fueled by specialized processors, such as GPUs, together with vast number of images available through the internet to foster the required training. Today, the rate of data growth is so fast that 90% of data in the world today did not even exist 2 years ago. This data growth has accelerated training and has led to realization of applications which were only a dream 10 years ago. Today, we use visual recognition in all kinds of places, so much that we take for granted the modeling required to do this calculation. Many cars are now sold with computer vision systems that help the drivers stay in lane or even park for you. And completely autonomous self-driving vehicles are already a reality. With this perspective in mind, let's look at how the open revolution in infrastructure space started with the genesis of the OCP. With a large percentage of the population online, data centers started growing at an unprecedented rate. By 2011, Facebook, along with others, realized that this exponential growth would require new ways of operating to support this growth. The rationale for OCP was simple. Exponential growth creates challenges in manageability and control, requiring an increased pace of innovation. Creating an open ecosystem allows for fast exchange of ideas. We could help solutions develop faster by breaking dependencies and breaking silos by disaggregation. This would foster collaboration between companies and create opportunities for efficiencies. Let me give you an example of one of the efficiency improvements. One of the most important efficiencies in data centers is power usage efficiency, or PUE. This is the ratio of the total power consumed by the data center compared to the amount of power used for IT. An ideal PUE would be 1.0. For an enterprise data center, a PUE of around 1.9 is considered normal. Facebook designed a data center with a PUE of just 1.07, making it one of the most efficient data centers in the world. This is a photograph of Facebook's first data center in Prineville, Oregon, which was opened in 2011. Inspired by the model of open source software, Facebook looked for ways to share the design prints for Prineville so that innovations and efficiency be available for the entire industry to use and improve upon. This design was one of the first contributions we made to OCP. The Open Compute project was launched on the 7th of April 2011, with efficiency, scale, openness, and impact as the charter. These still provide the cornerstone of OCP tenets that drive the focus of all we do within OCP today. The first OCP Summit was held in June 2011, with roughly 200 attendees. Facebook made its first three contributions at the summit, including the Prineville data center design. Every year since, we've contributed more of the technology we ourselves use in our infrastructure, from the building right down to the modules that go inside the racks. Over the past 10 years, the industry has enthusiastically embraced OCP and has worked hard to develop and share new solutions. Kudos to all of you for being part of this thriving community, collaborating and pushing the innovation envelope. Since the first contributions in 2011, There have been over 200 contributions accepted to OCP from 22 different companies. OCP's presence goes beyond the original starting in data centers. Today, we have device designs for networking, telecom, and IoT at the edge. And last year, software was added with 124 new software badges. OCP has established a thriving marketplace, and since 2017, over 141 products have been added to the marketplace. Since 2011, the community has grown from the 7 original founding members to more than 200 companies from many different application areas. The theme for the OCP Summit this year is Open for All, and it truly captures the sense of where OCP has arrived in 2020. Open for All means hardware to software, hyperscale to telco, going from large data center installations on a building scale to modular data centers, touching traditional applications to new and emerging ones, going from local geography to global scales, from systems to components. The journey so far has been amazing, but as we often say at Facebook, this journey is only 1% finished. With all the progress that we've made in OCP and the great work this community is doing, we're just getting started. So what lies ahead? There's much more to be done in the coming decade, with new challenges emerging. Let's take a look at some of the biggest challenges in front of us today. I've presented often on the exponential growth of network bandwidth demand within data centers, and how this is mostly driven by machine-to-machine communication and east-west across the network. While the power per bandwidth has consistently declined, it's not commensurate with the growth of the network bandwidth. We've seen that as a result, the portion of power allocated to networking is steadily increasing over time. This is a worrying trend. Power allocation in the data centers is typically constrained by high voltage distribution systems. If the total power available is limited, then to give more to networking means taking it away from the functions that run our business, such as compute and storage. Power has become one of the biggest emerging challenges. Another challenge is that software and firmware are becoming more involved in how we design efficient systems, and this too should be open. Some examples of how this is happening include Sonic, led by Microsoft, and work being done by open system firmware teams with collaboration from Intel and Facebook. OCP is also transforming with the entry of new players such as foundries and silicon IP experts, bringing innovation in silicon and components. We're shifting from a focus on the rack and motherboard to chiplets and interconnects, with projects in the ODSA working groups. But for systems to be truly open for all, they must be easier to build, manage, and deploy for all. Truly open systems require open software, including the entire tool chain to support the system. This includes the whole breadth and depth of the stack, including bootability, security, operability, validation, deployment, provisioning, and fault management. Let's take this idea a step further for a moment. What about extending this set of software frameworks to the entire life cycle, from design and engineering to testing and deployment, and even go beyond to troubleshooting and decommissioning? What I mean is, think co-design. Co-design considers not only hardware and software dependencies, but also dependencies across the different domains such as storage, networking, compute, and memory. I'll give you 2 examples of co-design that will be coming up in talks later in the summit. The first example is the new workloads such as machine learning pipelines shown here, where bottlenecks span many domains. This is a place where disaggregation does not help us, because resolving one bottleneck without addressing others simultaneously will not yield the required performance gains. A co-design approach would allow us to address the entire pipeline performance and simultaneously address bottlenecks on all fronts. Maxim and Devatsa will be giving a Facebook talk later which specifically addresses this issue. The second example is in the area of networking. Today, we think of network as a distributed system, but co-design of all the hardware and software components like NICs, interconnect fabrics, along with the kernel, becomes critical to ensuring all networking bottlenecks are addressed together. Solving one level may locally improve results, but not necessarily the whole network system. This example will be talked about in greater detail in another talk by Omar later in the summit. The broader question is, how does the community evolve to allow for faster interactions to accelerate innovation? This is not easy, but co-design, will be necessary to rapidly build on innovations. The next challenge is sustainability. As data centers grow, we must think of decommissioning as part of the life cycle. E-waste is growing at an equally rapid pace as we rush to innovate. Back in 2016, 49 million tons of e-waste was generated globally, and this is predicted to grow to 52 million in 2021. Just think of the number of servers that get EOL'd. According to Renew, 46 million servers will be EOL'd globally between 2019 and 2023. Facebook and IT Renew are working to address circularity by enabling secondary markets, but we need to align our efforts from hardware to software to make systems easier to consume when they're decommissioned from their primary life and enter their second life. Circularity is a growing area where IT equipment is fully utilized through multiple cycles. Facebook's data centers are the most energy efficient and water efficient data centers in the world, and we're always looking for ways to improve our efficiency. We've set a science-based target to reduce our operational emissions by 75% in 2020 compared to 2017, and have already reduced our greenhouse gas footprint significantly. In 2018, we reduced our greenhouse gas footprint by 44% from 2017. We're also committed to accelerating the renewable energy transition and have set an aggressive goal to support our global operations with 100% renewable energy in 2020. Designing, building, and maintaining facilities that are positive contributors to our communities matters to us. We approach sustainability from the ground up, from design and construction to energy sources, water stewardship, and responsible managing the end of our life of equipment. Imagine how the world will change in the next 10 years. The rate of consumption will grow. Challenges of power, cooling, and density will grow. The need for faster, streamlined system validation will grow, and the need for large-scale experiments to be performed will grow. The need for modularity, common platforms, profiles, and security will all grow. I can promise you, the next 10 years will be more exciting. Today, we prepare for the next decade. I'd like to highlight some of the new directions we're taking to overcome these challenges. To overcome the challenge of power efficiency in our network, we're driving higher levels of integration in our interconnect by co-packaging optical links together with the host silicon. For the past decade, we've used pluggable optics and optical transceivers, which are plugged into the edge of the switch card. Today, we see a growing problem with the power consumed by these network connections in overcoming the long signal trace between the switch chip and the optics. By moving the optics onto the board and closer to the host IC, we can overcome the signal integrity limits of electrical links out to the edge of the card. And by integrating further and co-packaging the optical device together with the switch chip, Facebook anticipates more than 30% link power reduction. To ensure the health of the marketplace, we need to have a diverse supply ecosystem. That's why we're working together with Microsoft to develop a set of documents to guide the market and describe the needs of end users. You can find out more about the project at the link on this page. And there are other ways to improve efficiency using a building block approach that leads with modularity and common platforms. These are two areas identified by the OCP Incubation Committee for Community Focus. Achieving a common platform and modularity will allow reuse and accelerate innovation through faster design cycles. It will minimize SKU proliferation and create value for the community. Facebook and others are already contributing modular and common platforms to the OCP portfolio via designs such as OCP NIC 3.0, OCP Accelerator Module, and ORV3 Rack Design. Open for all means we're open to other organizations too. OCP is collaborating with other open source entities, including Open Networking Forum, Linux Foundation, Telecom Infrastructure Project, and others to bring in their ideas. At the same time, we should strive to have OCP solutions shared and deployed by these organizations. As we enter the next 10 years, OCP will work on problems that relieve pressure on multiple fronts. Ease of development, by ensuring that the hardware co-design approach spans all platforms, compute, storage, and network. Ease of deployment with a focus on an open toolchain, which can allow for faster validation all the way from component levels to system and clusters of systems. Ease of reuse. Over the next 10 years, we should see an open innovation across the whole life cycle. And ease of modularity, sharing common and interchangeable modules to expand benefits. And with all of this, we will accelerate innovation. I touched on several concepts today for how we can collectively achieve more as a community. I want to capture all of that in a simple but critical ask. Share your ideas and be open, because openness is the best way to achieve what we all want for the future. And what we aspire to in the future is OCP innovation that reaches throughout all data centers, big and small, by the year 2030. Thank you.